All right, you are welcome back to our chemistry class. We have this question to solve. 0.25 mole of hydrogen chloride was dissolved in distilled water and the volume made up to 0.50 gm3. If 15.00 centimeter cube of the solution requires 12.50 centimeter cube of aqueous sodium triisocarbonate 4 for neutralization, calculate the concentration of the alkaline. In a question like this, the first thing to ask yourself is that which topic was the question drawn from. So the question was drawn from the topic stoichiometry, and I told you several on that stoichiometry is an important aspect in chemistry, both in the theoretical aspect and in the practical aspect, talking about the volumetry analysis and especially titration to be precise. Tackling a question like this, the first thing to do is to write out the equation of reaction where we have hydrogen chloride reacting with sodium triisocarbonate 4. Then this will give you sodium chloride with carbon dioxide gas and water. Remember, it is a neutralization reaction. We have gas here, we have this one is solid, and then we have aqueous here, and this one is equally aqueous. Then the next thing to do is to balance up. You balance the equation on both the left hand side and the right hand side. Here we have one hydrogen, we have two hydrogen here, then put two here. We have sodium is two, we have uh, two molecules here, then you can put two here also. Now you can, when you take a critical look, you see that all the atoms are balanced. The next thing to do is to ask yourself, what am I told to find? Calculate the concentration of the alkaline. You are told to calculate the concentration of the alkaline. Remember, it is a neutralization reaction, and the formula that we normally use is CaCa divided by Na. So permit me to partition the board like this. So for simplicity, is equal to CB over MB. Now, what are you told to find? We are looking for CB, and make your CB to be the subject of the formula. By cross multiplication, here I have CB, I have my CBVB with Na equal to CA with MB. Then by making my CB to stand out, I have CA divided by VB and Na. Now I can now start looking for each of these guys. I have my Ca, that's concentration of the acid. Coming back here, we have 0.25 mole of the acid being dissolved in 0.5 molar, 0.50 gm3. So it means concentration is not given, but I can look for it. So from the formula N is equal to Cv, I can have C is equal to N over V. So you can see that now. So therefore, I can come down here and say my Ca is equal to number of mole, that's 0.25 divided by 0.550. So if you do that very well, you are going to get 0.5 mole per dm cube. So that is the concentration of the acid. So now having done that, so I have, so I can, my volume of the acid, what is the volume of the acid? 15.00 centimeter cube of aqueous of the solution. Which solution? The hydrogen chloride solution. It means volume of the acid is 15.00 centimeter cube. Then what the next thing? MB, the mole ratio. So the mole ratio of the acid to the base, that is ratio 2 to 1. Ratio 2 to 1. Na ratio NB is equal to 2 ratio 1. 2 ratio 1. So MB is equal to 1, whereby my Na is what? Na is 2. So volume of the base, that will be 12.50. So having done that, the next thing is to start slotting in the values. Where we have CA, what will I put? I'll put my 0.5 multiplied by where we have VA, what will I put? We'll put 15. Remember, you don't need to convert because the centimeter will surely cancel centimeter. So NB, that will be 1. Everything divided by VB, the volume of the base, that is 12.5. And the mole ratio of acid, that is 2. Then multiply by 2. You do that very well, you're going to have this 0.5 multiplied by 5, that will be 7.5 divided by 25. And if you do that very well, you will discover that your CB will be equal to, that's 75 over 10 divided by, multiplied by, so 7.5 over 10 divided, by 25.5 over 10 over 1. So division there. So by the time you change it, that will be 75 over 10 multiplied by 1 over 25, and then we have 25 here, 125 here, 3, and we have 0.3 mole per dmq, or say 0.3 molar. Just put capital letter M. So ladies and gentlemen, brothers and sisters, the concentration of the base that will neutralize 15.0 centimeter cube of hydrogen chloride is 0.3 molar of sodium triazocarbonate 4. Thank you very much for watching. Bye for now.